Mr. Allen.
Yes, sir.
All right. So I'm back here. Shadi as well.
Yes, sir.
All right. So we're gonna do a couple more. Just a little last lap. So you can tell me what question you want to do. So Allen, you go first.
Sir, 2012 question 3.
Hold on a second. Hold on. Antoine, you're not coming on. I'm in a session now. So let's go through last look. You all right? All right. So basically, I'm just doing questions that person's asked me to do. That's what it's about now. Yeah, cool. Hold on there. What's happening here? Okay. Can I see the screen?
Yes, sir. Yes, sir.
Yes, sir.
All right. I need to bring up something to write down. That's the thing I'm trying to do. Let's do this. All right. Which number? Number 3 on this 2012?
Yes, sir.
Number 3. This one. All right. It's a trees. We're going way back though. We're going so far back. We're 2012. That's more than how much years ago? It could have come from one of more recent papers. 2012 is not even your current syllabus. But anyway, it says given that this is equal to this, which you should know, and that this is equal to that, prove this. All right, so I want us to prove this. All right. Now, first thing is that first thing is to recognize that the cost, hold on, the pen bigger thicker. The cost of 3 theta can be written as the cost of 2 theta plus theta. That's the first thing. Make away it's a smaller. All right. That's the first thing to recognize. That can be written as that. All right, and I'm going to expand this now as a compound angle. Expansion of cos is cos minus sine. So this is cos 2 theta, cos theta minus sine 2 theta sine theta. Cos minus sine sine. Cos minus sine sine. And this double angle, because look, we want to get everything here. Well, it's actually in terms of cos and sine squared, right? So they're telling us this one, but I say a sine squared here. I'm going to start with that. I'm trying to get cos, all right? So I'm going to expand this one now using this identity, the 2 cos squared minus 1. That is this. So this is going to become 2 cos squared theta minus 1 times cos theta. That's this one, is this. And then I'm going to expand this one, which is same as 2 sine theta cos theta. And then I'm multiplying that with this sine theta. All right, expand this out. This time this. Well, actually, if you look at this answer here that they're getting, they have factorized 2 cos theta. They have factorized 2 cos theta. All right, so let me see. Let me see first. So they have factorized 2 cos theta. Let me expand this out first. So I'm going to write this as 2 cos cubed theta minus cos theta. That's what this expands out into. And this one becomes minus 2 cos theta. That's 2 cos theta. Sine theta times sine theta is sine squared theta. Sine squared theta. And then now, I'm going to write this sine squared as 1 minus cos squared. All right, write that as 1 minus cos squared. So I'm going to get 2. I can factorize cos out of everything now, you know. Yeah, I can factorize it now. I can factorize cos over everything now. Just like this 2 over 2 on it. So what I'm going to do, I can factorize cos now. So for this one, multiply this one by 2 over 2. 2 over 2. So I can get the 2 cos theta out of this, 2 cos theta out of this, and 2 cos theta out of this. Right, so then this becomes a factorize 2 cos theta, and out of this one, I'm going to be left with cos squared theta. Out of this one, I'm going to be left with minus sine squared theta. And out of this one, the 2 cos gone outside now, so I'm going to be left with minus a half inside the bracket, and that is it. That's what they tell us to show right here. See that?
Wait, so where did 2 and 2 come from?
Because I want to be able to factorize 2 cos theta. It's when you're doing a proof, you have to look at what they have now. No, initially, it was not, there's none there. That's all I had. But I want to be able to factorize 2 cos theta because they have a 2 cos theta in theirs. And this is the only one that didn't have any 2 cos theta in it. So I have a 2 cos theta in this one, and I have 2 cos theta in this one. This one don't have any 2 cos theta, so what I do, I put one in. I multiply by 2 to get the 2 cos theta, and then divide it by 2. So when I factorize 2 cos theta out of this one, I get this. When I factorize the 2 cos theta out of this one, right? These gone outside, but the minus sign come here. And then when I factorize the 2 cos theta out of this out here, this 2 under here, which represents a half, come back there. See now? Sometimes you have to make adjustments to get what you want. You have to make adjustments to get what you want. Then it says now use an appropriate formula, right? Show that this thing is equal to that. All right. So this is what we call the factor formula. That this equals that, what you know. All right. So the half of sine 6 theta minus sine 2 theta in the bracket becomes equal to half. And in the bracket, this is what we call the difference of two signs. The factor formula, difference of two signs. So that you would have on your formula sheet. Difference of two signs. The difference of two signs is twice the cost of half the sum times the sign of half the difference. Twice the cost of half the sum times the sign of half. Where I get that from? I'm sure where I get that from. These are things that it's good to know, but I think they'll be on the formula sheet if you need to use them. But see here, I don't know if it's on this formula sheet up here. Let me see. If this is a formula sheet, I know the formula sheet on this one to show you. But when you know the trigger identities, these things will come very easy. So look what they're gonna use for this one now. It is this. That the cost, the sign, sum of two signs. This is what I'm using. The sum of two signs, like sine of A plus the sine of B is twice the sine of half the sum times the cos of half the difference. The sum of two signs is sine cos, twice the sine of half the sum, that is sum these and half it. That is A plus B over 2 times the cos of half the difference, A minus B over 2. Ever said that before? They have the difference of two signs, the sine of A minus the sine of B. So on the must-know sheet I gave you yesterday, this becomes twice the cos of half the sum times the sine of half the difference. That is the difference of two sines. So the sum of two sines is sine cos. The difference of two sines is cos sine. Then we have the sum of two cos now, like cos A plus cos B. Now the sum of two cos is cos cos. So it becomes twice the cos of half the sum times the cos of half the difference. And then you have the difference of two cos, which is cos of A minus the cos of B. That becomes what we call minus sine sine. So the only one that starts with a -2. So it's minus twice the sine of half the sum times the sine of half the difference. So this question, which is sine of 6 theta minus sine of 2 theta, is asking us to use this one. Difference of two sines. So that the A is 2 theta and the B is 6 theta and the B is 2 theta.
Sir, you said that is on the formula sheet.
I think it's in the formula booklet. I think it's in the formula booklet.
Sir, we know the first three, you know, sir, but like the fourth one.
But the fourth one easy, just sine and put a minus in front of it. No problem.
No, there's no problem. It's just that we're not really used to seeing the fourth one.
Oh, yeah, man, they all go together. This is sum of two sines, difference of two sines, sum of two cos, difference of two cos. So this question up here is a difference of two sine question up here. I want to apply it now. So this becomes cos sine. The difference of two sine is cos sine. Cos sine. What do I mean by cos sine? I mean that the cos comes first. So it's twice the cos of half the sum. That's this plus this over 2. 6 theta plus 2 theta over 2 times the sine of half the difference. That's 6 theta minus 2 theta over 2. That's 6 theta minus 2 theta over 2. That's what in there becomes first. And we're working towards again. It's a shows it equal this, right? Shows it this equal that. All right, so we're working towards this thing right here. We're working towards this. All right. So let's simplify. So this half cancels this 2. That will be gone. And then this becomes cos of 4 theta over 2. which is 2 theta. So I get cos 2 theta times the sine of half the difference. So this is 6 minus 2 is 4. 4 divided by 2 is 2. So I'm going to get sine 2 theta from here. All right. And this now expands out into 2 cos squared minus 1. So it becomes 2 cos squared theta minus 1. That's what this is. Times by this right here, which is sine 2 theta, which is what they have right here. See there? Is it this? Same thing. All right, that is that. When you know your trigger identities, and I tell you them things are easy, and you know, but you have to learn them, have them in your head. You know them in your head. I'm writing this out of my head, and I'm not looking at anything. All that is coming out of my head. Next part says, hence or otherwise, they want us to solve this. They want us to now solve this. And it's a hence or otherwise question. So they want us to solve that now between 0 and pi by 2. So to solve this equals 0, it's like we're solving this equals 0. Understand? So then it means that you're solving this thing. Alright, so look at it this way. You're solving sine 6 theta minus sine 2 theta equals 0. I can multiply by the half, this side by the half. It becomes the same thing. But this whole thing with the half now is actually now equal to this thing. So it becomes equal to 2 cos squared 2 theta minus 1 times sine 2 theta, and that is equal to 0. So you're solving this now. So that this factor equal to 0, which is going to give us cos, cos 2 theta equals, with a square, equals a half. They're going to square root it and get cos 2 theta, sorry, would be plus or minus, because square root it, 1 over root 2. 1 over root 2, just square root that. And then this one will be equal to 0, right? So this one will be equal to 0. So the other option is that the sine of 2 theta equals 0. Sine of 2 theta equals 0. All right, so those are the two things that you're solving. Two things, but you're solving between 0 and 90. So you really only want the first values. All right, you're solving between 0 and 90. Let me show you something. If you're solving this between 0 and 90, we see what we have here solving for initially is 2 theta. So see here, look at this, which kind of makes sense. If you want theta to be between 0 and pi by 2, if you want theta to be between pi by 2 and 0, then when you're calculating the 2 theta here and here, you're going to have to double the range that you're finding them in. So 2 theta is going to have to be up to pi and 0. So I multiply this by 2. I have to multiply this range by 2 to get what range I need to find 2 theta in. So between 0 and pi means that I'm working first 2 quadrants. That's where my 2 theta must be in the first 2 quadrants. So when I'm solving this one, my cos is positive or negative. When I draw the quadrant diagram for this one, I would want all the quadrants. Why do I want all the quadrants? Because I want where cos is positive and also where cos is negative. So I want all the quadrants. And the principal angle for this, which is alpha, would be cos to the minus 1 of the 1 over root 2. Well, this 1 over root 2 is same as root 2 over 2, which is the value that you get from 45 degrees, or pi by 4. So the alpha will be pi by 4. A lot of the time you can do this question and use a calculator. You don't need no calculator. So this quadrant over here is pi minus pi by 4. All right, and based on this range here, we only need to calculate 2 theta in that range between these two first quadrant up here. So what it means then is that the 2 theta is now equal to this value and this value, 2 theta that is. So the angle which is 2 theta is equal to pi by 4, and this pi minus pi by 4 actually becomes 3 pi by 4. This becomes 3 pi by 4. 3 pi by 4. Now if we divide by the 2, you get theta equals pi by 8 or 3 pi by 8. Those are the values that I get from this side. Then over here, I'm solving sine 2 theta equals 0. If I'm solving sine theta 2 theta equals 0, again, I want the first two quadrants. So my 2 theta, this one kind of easy because it's 0. So the 2 theta is going to be 0 because sine of 0 is 0. It's also going to be pi. Sine of pi is also 0. All right, so now divide by the 2 now, I'm going to get theta equals 0 and pi by 2. So those are my answers right there. These angles and these are my answers. That is it. All right, those are my angles. All right, let's look at this one now. This one says, find all the possible values of theta. Find all the possible values of cos theta, right? Cos theta. I was just wondering all for this. All right, let's look at it. So give us this thing to solve now, which is 2 cot theta, 2 cot squared, 2 cot squared theta plus cos theta equals 0. That's what we're given to solve. Not one way to solve these questions. We can work with the fact that cot is cos squared theta over sine squared theta. Can work with that, put 2 on this, and then put cos theta here equals 0. And multiply 2 by sine squared and get 2 cos squared theta plus cos theta times sine squared theta equals 0. Then I can factorize cos theta out of these two terms. I would get cos theta into out of this, I would get 2 cos theta. Out of this, I would get plus sine squared theta equals 0. Then either this equals 0, so cos theta is equal to 0, or this equals 0, or 2 cos theta plus sine squared theta equals 0. But then this can be changed into 1 minus cos squared theta and put the cos squared with that. So that's what I'm going to do. All right, so let me make a note of it in red, that this sine squared is 1 minus cos squared theta. So I'm going to expand that as such. So I'm going to get 2 cos theta plus 1 minus cos squared theta equals 0. Make this term positive. So I'm going to multiply 2 by negative 1. Right, what's happening here? Right, I'm going to multiply 2 by negative 1. This thing, so I'm going to get this comes positive, which is cos squared theta. This comes negative, which is minus 2 cos theta. This becomes a minus 1 equals 0. And think about this now, this can factorize, this can factorize. So you're going to use the quadratic formula. So the cos of theta is going to be minus b, the b is 2. The minus give me a positive 2, minus b, which is 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times A. The A is 1 right here. Times the C is negative 1. All over 2A. A is 1. So cos theta equals 2 plus or minus 2 plus or minus. Now this becomes a 4 plus a 4, that is 8. So I get the square root of 8 over 2. So those are my values. Cos theta equals 0 from the top here, and cos theta equals the plus of this and the minus of that. So those are the 3 values that cos theta equal to. That's my solution. And they ask me for alpha theta, sorry for theta. Just simply ask me for cos theta, is what I found. That is it. All right. Guys, you must practice from the most recent papers. Do an exam from the most, you must be doing it. This paper 2012 is a whole syllabus system. This don't even have reason and logic on it, or binary operations and like that. It's an old syllabus, this one, old. Night before exam, I'm supposed to be practicing from questions that are closer. 2023, 2022, 2021, 2019, them kind of years, they're supposed to be practicing from at this stage the night before exam. The only issue is when you're learning the topics and you want some questions to do, but no, not before exam, you're supposed to do questions from the more recent papers. I'm supposed to are reading at 2012. That's why I want one special question down there. And there's so much them kind of question on the more recent papers. Which question you want me the next? Who else have a question?
Sir,
The
you can do
2018
2018. Sir, you can do 2018 number 6. You can do
2018
number 6, 2018.
Let me see. I was doing some questions earlier. Now, where were you?
Oh, sir,
Antoine?
with their school.
I feel tired now. I'm starting to feel tired now. Let's hope I never do number 6 yet. The last question on this paper. Okay. 2018, number 6. Last mosquito. Number 6. This one. This one?
Yes, yes, sir, yes, sir.
Do the question the other day. Now, where are you? All right. Question gives us this function. This, that, and that. So the function is on, man, what did I do? The function is on this when x is less than 1. It's on this when x is greater than 1. And it's equal to 0 when x is equal to 1. This is a continuity question. It says determine whether or not the limit of f exists at x equals 1. Now for the limit to exist, the limit from the right and the limit from the left must be equal, must be the same, right? For the limit to exist, right? The limit as x approaches 1 from the left of f of x has to be equal to the limit as x approaches 1 from the right of f of x. That is when the limit exists. So I'm going to record each of them and see if them equal the same thing. All right? That's what must happen for the limit to exist. Let me see what space we have. Not a lot, but let us work. So let's do this one first. So the limit as x approaches 1 from the left means that you're coming from a value less than 1. It means that you're on this function, less than 1. You're on this function. So the f of x is on this function when you're approaching -1 from a value less than 1. So you've taken the limit of x to the 4th power minus 1 over x minus 1. All right. So what you have to know you need to get x minus 1 out of this. So I'm going to factorize the numerator. That's the difference of 2 powers. Because this x minus 1, x to the 4th minus 1, same as x to the 4th minus 1 to the 4th. Put on a 4 then, right? Since it wasn't given. I if you could do long division with this and divide it, but you don't have to do that. That's the difference of 2 powers, which you all should know. So then this becomes equal to the limit as x tends to 1 from the left of x minus 1 bracket. An expanded form of this now is going to be x cubed plus x squared plus x plus 1. And that's because this is a 1. So all the powers of 1 is going to be 1 anyway, divided by x minus 1. So these x minus 1s cancel each other. This and this cancel. And then you can apply this one everywhere else. Apply this x equals 1 here and there and there and there. So it's going to work out to be 4, obviously, right? So it's going to work out to be 4. So this is equal to 4. I'm going to test the limit from the right now. That's what we get. The limit from the right. The limit as x approaches 1 from the right. When you're on the right, means that you're now on this function. Now you're coming from a value that is greater than 1, so you're on the right. So you're taking the limit really of 4x. But this one is straightforward. It is equal to 4 times 1 is equal to 4. So since the two of them equal the same value, the limit exists and it is equal to 4. So you can say, therefore, the limit as x approaches 1, because the 1 we don't put a sign on it, it means both sides of f of x is equal to 4. And you can say, yes, it exists, right? Exists.
Wait, sir,
Yes.
you couldn't just differentiate the numerator and the denominator and get the same 4.
Differentiate the numerator. Differentiate the numerator and the denominator. That's a method. I think that's a method that applies sometimes, you know. I think that's a method that they apply, you know. But I've never practiced doing this using that method. I've never practiced doing it that way. So you're saying differentiate the numerator and get 4x cubed. You see? 4x cubed over x. That's what you're saying.
Yes, sir.
And you apply the 1, you'll get 4. All right, I guess. And this one, I differentiate that one too. But you're getting the gradient function, not just a method there, no. I don't know. That's something I have to look into. I've never done it that way. Now I'm just work it out the traditional way. I'd have to look into it.
Right.
But I kind of vaguely remember that that is a method that can be used when you're doing limits. You can differentiate it out.
All right.
Simplify it, yeah. But the limit exists, right? So you can say it exists. You saw that method somewhere? We differentiate it?
Yes, sir. I think I remember like some YouTube guy, him differentiate. Him did I do a limits question and him differentiate it. But I don't really remember fully.
Oh. I something I have to look up. I have to look it up. I don't quite remember, but I vaguely remember something where you can differentiate it. But I prefer to just stick to this for the time being. I would have to try it with some other weird function and see if it works for all functions. That's what I would do. Try it for all different kind of functions. So going forward, every time I do a functions question now, a limits question, I'm gonna try it that way and see what. And see if I get the same answer.
All
That's
right,
what I
sir.
start with. Yeah. And use empirical data to see if it's a method worth sticking to. All right. This one now says determine if function is continuous at x equals 1. So to determine if a function is continuous at a value, there are certain conditions that must exist. You have to know the conditions. So for it to be continuous at x equals 1, what must exist? Right? So what we must have for continuous? So we must have this. Must have the following things. So for the function to be continuous at x equals 1, these are the things that must happen. the limit as x approaches 1 of f of x have to be equal to f of 1. And both must be defined. They must exist and must be defined. So when you take the limit, as x approaches 1, it have to equal f of 1. It have to equal the same thing. So when I say the limit of 4 already, you know, the question is, what is f of 1? Let's look back at the table. F of 1 is 2. So therefore it failed. See there? I'm going to say f of 1 is 2 because this is when x equals 1. Right here, f of 1 is 2. So the limit and f of 1 not equal. So the function is not continuous. For the function to be continuous, everything have to be consistent and in sync, you know. Right? So you're gonna say yes or no. It is not because this equals 2. So you're gonna say but f of 1 is equal to 2 and the limit as x. I just say them not equal. I say but them not equal. So you're gonna say but the limit as x approaches 1 of f of x is not equal to f of 1 because you're going to tell them that 4 is not equal to 2. And so therefore, f is not continuous. Continuous. You have to say at. You have to specify the point. This line is very important. At x equals 1, you have to say this. You have to specify the point where testing continuity. But the function can be continuous everywhere else, you know, except here. You have to specify the point always where testing continuity. All right, let me show you another thing where they say this part, f must be defined. So for example, if the question gave you same function right here, so, right? But it did not give you this at all, this. And all it gave you was where x is less than 1 and where x is greater than 1. I don't know what f of 1 is. Then it means that f of 1 is not defined. It's not given. You don't know what it is. It is not defined. And therefore, you could not say that this function is continuous at x equals 1 because of this. F of 1 is not defined. I don't know what f of 1 is. It's not defined. It's like if you draw the function here, it don't have no value when it reach 1. So if you sketch a graph of a function like this, for example, let's say the left part of the graph up to 1. Let's say the graph, let me sketch it and show you what I mean. Let's give an example of what I mean. Right? There's no value at 1. So it's like you have the graph and y-axis, x-axis, right? And you have the point where x equals 1. So that this part of the graph, let's do argument say, let's say going like this. And when you reach 1, see you reach 1 right here, so let's put that on in red. Right here is where x equals 1, right? Right here is where x equals 1. When you reach there, so now, the function change and become this function, 4x, which is just a straight line graph going up like so. When it's right at the point where x equals 1, you have a hole in the graph. Because there's no value for x equals 1. And the function is discontinuous. So this part over here would have been 4x. And this part over here would have been x to the 4th minus 1 over x minus 1. And x equals 1. So our limit, the limit exists. And if you're showing the limit graphically, the limit is 4 as this here. So map onto a y value of 4. Because the limit is 4. The limit is the y value the function approaches as you approach that x value from the left or from the right. So the limit is 4. So that corresponds to there. Right? But it's not continuous because the f of 1 is not defined. If this was the question. But that is not the question. So let me just take these out. All right, and leave that. That's it. Another part on this question you want to be done, I just start. Okay?
Yes, sir. Just that pretty much.
All right. Who else? Who else?
2022 number 4 from B.
2022, number 4. 2022. 2022, number 4. 2022. Number 4. Sit. Which part of it? 4B?
From B, yeah, starting from B and going down.
All right, 4B. All right, that's a vectors question right here. All right, so question said, determine the equation of a plane which passes through this point and is perpendicular to this vector. Well, this part is easy, but this is a normal to the plane, and that's the point. And the equation of a plane is r dot n. You know the normal and the vertical and the normal and a point. All right, so the equation of a plane is r dot n equals a dot n. In this case, this is the n. Let's call it b, but this is the n. And this is a known point. So that is the a. That's it. And then what they said determine the equation. So we're gonna keep this as r. They said the Cartesian equation, they would write it as x, y, z. This r right here. It represents points on the plane. All right. So I'm gonna write this as r dot, and the n is this vector right here. 3, 2, 4. Right as a column vector. 3, 2, 4 equals the a is this one now. 0, 2, minus 2. 0, 2, minus 2 dot the n. N is still this. 3, 2, 4. I wrote that out. So this becomes what is work out to? So we can just work out what this is right here. So let's put what it's equal to. So this time this is 0. This time this is 4 plus 4. And this time this is minus 8. Minus 8. So then, because they give me the vector in ijk format, I'm giving them back this in ijk format. So this becomes r dot. This becomes 3i plus 2j plus 4k equals this value out here. What is work out to? This work out to negative 4. Negative 4. That is it. That's the equation of a plane. All right, next one. Determine the angle between this vector and the x-axis. So to find the vector, find the angle between two vectors is to find the angle between their directions. So the question is, what is the direction of x-axis? The x-axis can be written as the line r equals I. Like that. That's the direction of x-axis, I. So I'm finding the direction between this vector and this vector. Right? But x-axis is just I. X-axis. The direction of the x-axis is I. Alright. So if I write them as column vector, so I'm gonna call them vectors, right? So I'm gonna call this vector V, or this vector V. This one, call it V. So the V equals 3 minus 2, 0. And I can use two components, you know, because this just have that I alone. But I'm gonna call that vector 3 minus 2, 0. And then the x-axis as a direction vector, I can call it R. It is equal to I. Sorry. It is equal to I right there. So I can write it as R equals 1, 0, 0. So I'm trying to find an angle between those two vectors. Easy as that. All right. So that angle is theta equals cos to the minus 1 of a scalar product. That's V dot R over the modulus product. The modulus of V times the modulus of R. Let's call them that. V and R. All right. So this becomes equal to cos to the minus 1. What is the scalar product? I'm multiplying this time this, I get 3. Everything is going to be 0. This times this is 0, and this times this is 0. So I'm just going to get 3 up here. 3 over the modulus of this now, square root of 3 squared plus 2 squared. And then this now, the modulus of that is just 1 times 1. Modulus of a unit vector is 1. So you're working this out to the calculator now and get your angle. All right, so I'm going to be cos to the minus 1 of 3 over the square root of, this is 9 and 4, 13. 13. So I get 33.7 degrees. That's it. All right, what else I want to stop? What else? Then we'll come down here. It says the parametric equation of a line is given as these, right? It says determine the coordinates of the point where the line crosses the xy plane. Now watch this now, it's quite simple. On the xy plane, you're on the xy plane, then the z is equal to 0. You're on the xy plane, so the z value is 0. The z value is equal to 0 on xy plane. Now this point is on the plane at that place, you know? So this equals 0. This equals 0. So I want to use that. And so okay, this equals 0. So it means then that the 4 minus 2 lambda, which is a z, 4 minus 2 lambda is equal to 0. So the lambda equals 2. Once the lambda equals 2, you can take this 2 now and plug it in here so and get the x, and plug it in here so you get the y at the point. So the x value at that point becomes 2 plus 5 times 2, which is 12. And the y value becomes negative 3 plus 4 times 2. This is 8 minus 3 is 5. That's 5. And so the point is, this is x value at the point 12. This is y value at the point 5. And the z value is 0, 0. That is the point. Go to that.
Yes, sir.
All right, down here now. This question is a locus. A locus. It says a point PXY, bam, moves in the XY plane such that it is the same distance. All right, a nice question here. It is the same distance from this point as it is from this line, x equals 3. And you want to sketch a diagram. When you're doing a question like this, you want to sketch it up. All right. So I'm going to put my y-axis, my x-axis here. All right. And you must always put, when you sketch it up, always put the locus in there, in this quadrant, where the x and y value positive, right? It will work out itself. I want to put in line x equals 3. This line x equals 3. Let's put it right here. X equals 3, the vertical line. X equals 3. Every point on this line, the x value is 3, right? X value is 3. I'm going to put my locus point here. Well, put this point A, 1, 2. Let's put it here. So 1, 2. Let's zoom it up. So this point is 1, 2, A. Is the point 1, 2. And I'm going to put my locus point maybe around here. So point P, X, Y. And what they basically said is that this distance, let's use a different color for the distance. Let's use purple. This distance to this line, it has to be a perpendicular distance, is equal to this distance here. Those two distances are the same. Let's call this point up on here, so B. Let's just call this point B to reference it right here, B. So what they have basically said is that PB is equal to AP. All right. Remember, you see the coordinates of B right here. is going to have the same y value as this, you know? So this is going to be the point 3y. So you see the length here is just the difference between the x value here and the x value here. You know? That's this length. And then this length now, you're going to use length of line formula between these 2 points. But remember now that this length right here, this length is just this x value of 3 minus x. So this length is 3 minus x. This is 3 minus x. So we need an expression for this length now and put it equal to 3 minus x, all right? So that's how we're going to get the locus. Simple as that. But it's always good if we can sketch it out, what they have said. Put what they have said on the diagram. So I'm going to say that AP is equal to PB. The AP is the length of line formula between these 2 points. That's the AP. So it becomes the square root of the difference in x squared, which is x minus 1. X minus 1 squared plus the difference in y squared. Y minus 2 squared. Y minus 2 squared. And that is equal to PB. Which is equal to 3 minus x. 3 minus x. That's a locus right there. So determine equation of locus. See there? That is it. But sometimes I want to simplify it down and thing, you know, get down to simplest terms as far as possible. So we can square both sides to get rid of the square root. So we'll get x minus 1 squared plus y minus 2 squared equals, I'm going to square this now. It's 3 minus x squared. I don't think bother waste time working it down because they didn't tell us, but this is a locus. Understand that, guys? If you expand it out, if you expand it out, the x squared is going to be eliminated. The x squared. They're going to produce an x squared on this side. I'm going to produce an x squared on this side. The x squared is going to be eliminated, but we're not going to get into that now. Just showing you this method. Remember, right here, so it's perpendicular, right? Right here, so it's perpendicular. Right here. So this line is a perpendicular distance from the line. That distance, that's it. That finishes that question. No, yeah, that question done. All right, boss. Who asked for it? Okay?
Yes, sir.
Alan, you have no other question?
Um,
Alan?
2021.
Huh?
I thought they won't mean sir.
That's the only one you wanted?
Yes, sir.
Oh, all right, cool. David, you said something a while ago?
2021, number 3C.
2021. GC, where are you? 2021. GC. It's up the top. That's one. 2021 GC. Oh, this we did earlier today. GC. This one? This one? That is GC. That is GC.
Wait, number 3?
Oh, 3C, I said. All right. So I want 3 part C. All right, let's see. 3 part C. All right, let's look at 3C. GC. That's this one. All right. That's a nice question to solve. That's a nice question to solve. All right. Let's do it. Now, the first thing I'm going to tell you, if they do not tell you a range of answers, they must give the general solution. General solution. If they don't tell you a range. So they didn't tell anything about theta is between pi, 2 pi, and 0. You don't tell anything like that. Once I don't tell you a range, you have to give the general solution. All right? All right. Multiple ways to do this. All right, let's do it 2 ways. See what happens. More maths equals better maths. So I'm going to use a method first where I expand out this compound angle. All right, I'm going to use that method first. And I'm going to look to use another method afterwards and see if we get the same answer. I'm thinking of writing this cos theta as a sine of pi by 2 minus theta. Right? If I do that, it will be equal to the sine of theta minus pi by 3. And then essentially, this result, this angle, will be equal to that angle. They would be equal. But then you want the general solution, and that might be where the tricky is. You get me? So that is that. So this will, you could treat this as your angle, the original angle, and then you put the general solution on this angle over here. But let's do it this way first, which is to expand this out the right side as a compound angle. So let's look at it. So I'm going to keep the left hand side as cos theta. So I'm going to do cos theta equals, I'm going to expand this now. It's going to be sine cos cos sine. Compound angle for sine is sine cos cos sine. So it's going to be sine theta cos pi by 3. This is a minus, and the sine we expand, you put a minus here. Sine cos cos sine. So you're going to have cos theta and sine of pi by 3. All right, so much space we have. Kind of want to be able to do it half and half of the page. Shift this over here. Take a small and zoom up. All right, that's what we have. All right, let's put in what these values are now. Right, now this pi by 3 is actually 60 degrees, right? So you must know that the cos of 60 degrees is a half, and the sine of 60 degrees is root 3 over 2. So this becomes cos theta equals, this becomes a half, so it becomes a half sine of theta and minus, this is root 3 over 2. Sine of 60 degrees is root 3 over 2. The pi by 3 is 60 degrees, so this is root 3 over 2 cos theta. All right, good. Then I'm gonna go now. I'm gonna go now, and I can consolidate these two together. Okay, I multiply 2 by 2 first. Multiply 2 by 2 to get rid of that first. And so I'm going to get 2 cos theta equals sine theta minus root 3 cos theta. Now let me tell you something now. Anytime you're solving, I can bring this over here, so with this still now. I bring it over. Let me bring it over. So I bring it over. I'm going to get, watch what I'm going to get. I'm going to get 2 plus root 3 times cos theta equals sine theta equals sine theta. Then when I have the sum of sine and cos like that in an equation, I can divide through by cos and form tan. I can divide this side by cos theta, divide this by cos theta. If I do that, I'm gonna get, if I divide both sides by cos theta, right? Divide both sides by cos theta, divide by cos theta, then I'm gonna get that this side becomes 2 plus root 3. 2 plus root 3 becomes equal to, and the sine over cos is tan theta. So I'm doing the general solution for tan now. So if I turn it around, it is tan theta equals 2 plus root 3. What's the general solution for tan? I'm right here in thing. So if tan of a function of theta equals k, then the function of theta general solution equals tan to the minus 1 of k plus n pi. Remember, if this value is 0, then f of theta equals just n pi alone. All right? if you remember that. But anyway, that's what it is. So basically then, using this as my general solution for this, I can say that this then becomes that theta is tan to the -1 of the 2 plus root 3 plus n pi. And here you have to say n is an integer. Let's say it. You have to say n is an integer. So we're saying the same thing here as well. N is an integer. You have to say this statement, n is an integer. So we can work this out now. That's what the calculator gives us. So we can make a comparison. So my theta becomes equal to, I'm going to see what it becomes. Maybe we get a nice good angle with it. Let's see what the calculator gives us. Let's see. And I want to look at doing it another way, because more maths equals better maths every time. So I'm going to get tan to the -1, put the calculator in radians of 2 plus root 3, 2 plus root 3, and I get that in radians. Let me see if we can get that in terms of pi. Let me see if everything in terms of pi. See there, voila. 5 pi by 12, beautiful. Beautiful. So this becomes 5 pi by 12 plus n pi, where the n is an integer. So that's my solution. All right, so maybe that is a safe way to do it, like that. Safe way to do it. But more math equals better math. So let us look at the other wheel dimension and just try and see what happens. The other way. Because when I saw it in my brain, I said, yeah, can do that. So I'm going to take the same equation here. I'm going to use the identity that says cos theta.
Wait, sir, you can zoom out back for a second.
Like that.
Yes, sir, thanks.
All right. So now, we're gonna see that this cos theta and this side same as sine of 90 minus theta. All right, the cos theta here. We write as sine of pi by 2 minus theta. So my equation, this equation is going to become sine of pi by 2 minus theta. That's what the cos theta becomes, equal the sine of theta minus pi by 3. So I know my angle, I know my solution. This is equal to that. I don't have to do anything. The angles are the same. But I have to consider the general solution for sine still. Right? But the general solution for sine is this. Just that I know that the angle, the angle equal the angle there. That's what the answer is. The angle equal the angle there. Because it's like you have this and taking sine to the -1 of that. It's going to give you the angle. So it's almost like you're saying, from right here, so where you are now, it's like you're saying this angle, which is pi by 2 minus theta, becomes the general solution, sine to the -1 of this value. What is that value? Sine of theta minus pi by 3. If you get the inverse sine of a sine, you get in the angle, and you're able to know pi minus sine to the -1 of that same way. So you're subtracting this angle as well. All right, so it makes sense. It makes sense. It makes sense. So let's see if we get the same answer doing it that way. All right. So my angle, let's write the rule for the general solution for sine first. So if sine of a function of theta equals k, right? Equals k. Then the general solution is that f of theta is going to be two-part result, like so. Sine to the -1 of the k plus 2n pi and pi minus sine to the minus 1 of the k plus 2n pi, where the n is an integer. Therefore, add that as well. So put it in blue. N is an integer in there. All right, so you have to always make sure you state that. So that's the approach we're going to use. So what happened now is like, this is like my k, right? That is like my k. And this is like my f of theta. So I know the sine to the minus 1 of a whole of that. I'm actually getting that angle. See it here now. I'm solving this now, this thing. So I'm going to get that the f of theta, which is the pi by 2 minus theta, pi by 2 minus theta, becomes equal to, let's put it as a piecewise product, just the same. And if I do sine to the minus 1 of this, I'm going to get the angle, which is theta minus pi by 3 plus 2n pi. Then I'm going to get pi minus this angle, as pi minus this angle, because this is the same angle, you know. So whatever angle I have here, I'm doing pi minus it. So it's pi minus this angle. That angle is boom bang. That angle is theta minus pi by 3. I'll show the mathematics work like magic now, right? I'm seeing it. Let me make this a little bit smaller. And zoom up. Right. So I'm getting this now, right? So after add my 2 pi to this, my 2n pi to this now, add 2n pi to this now. So I get plus 2n pi. And remember, put it in red, that the n is actually an integer. Alright, n is an integer. Well, look what is going to happen now. My pi by 2 minus theta is going to be equal to, what will this one work out to? This one work out to what it is. Stays what it is, right? This one stays how it is. But look at this one now. Look at this one. What happens with this one, the second one, right here? Or to expand it out, it will become pi minus, it will become the pi minus give me plus. So it become pi plus pi by 3, right? Look, you know, this expression, what is it becoming? Pi plus pi by 3, that's 4 pi by 3, 4 pi by 3. But then this minus theta giving me minus theta now. And then I'm adding back this plus 2n pi. So see the problem here? So the problem here now with this one, put them black. You may have this minus theta on the side here. I may also have minus theta on the other side of the equation. Then they cancel. They cancel each other. So it therefore means that this result, this part of it, is not producing any result. It is not valid. Not valid. Yes? Push the door, push the door. Who that? Yes, sir. Oh, I'm soon come. Yeah, man. All right, cool. All right, yeah, man, no problem. Easy. All right.
Sir, wait, it's about not valid.
Because this expression, look at it again. This expression here is going to become this expression in red, don't it? Remember, say I put over here so equal over here so now we know. So if over here so equal over here so, I have minus theta upon the side and minus theta upon the side. The minus theta is eliminated. You see that?
Yes, sir.
Right. So it means this part of the pairized product is not valid. The owners are not valid. Kind of producing in the result. So my only solution is this. And up here, so. See that? So I can go forward and say my only solution is in that area. My only solution is up there. So I can proceed and say this equal all of that. is my solution, and then simplify it down. So I'm gonna say pi by 2 minus theta equals theta minus pi by 3 plus 2n pi, where n is an integer. My solution rests in this. Let's consolidate the thetas now, right? So this theta come over here, so add with that, give me 2 theta. So I'm gonna get a 2 theta over here, so. And then this pi by 3 go over here, so I add with that, right? Add with that. So I'll get I get pi by 2 plus pi by 3. Let's work out what it is. This is same as pi by 2, that is 3 pi by 6. And this is 2 pi by 6. They give me 5 pi by 6 together. So them two here give me 5 pi by 6. So this and this can give me 5 pi by 6 over here. So 5 pi by 6. And then this plus 2n pi going to come over and give me minus 2n pi. So let me shift this over and shift this over some more. Shift this over. Right, so I'm going to get minus 2n pi. And then all I have to do now is what? Divide through by the 2 to get the theta. Right? Divide through by 2 and I will get the theta. So if I divide through by 2 now, this will become 5 pi by 12. 5 pi by 12. This will become n pi minus n pi, and that equals theta. Now you might say, so this way, if I turn this around now, it really means that theta equals 5 pi by 12 minus n pi. Again, the n is an integer. So I got this result, circle it now. I got this result, doing it that way, and I got this result, doing it that way. Are they the same? Somebody tell me if they're the same. Would I get this as correct and get that as correct? Whichever one I did. Are they the same? Yeah, the only difference is that I have a plus here, so I have a minus here, so. Are they the same? Are these two equations, these two solutions, will these two solutions give me the same values for theta? Somebody answer now?
Sir,
Yes.
Well, no, let me hear what I say. Yes, they are the same because n is an integer. An integer is a positive or negative whole number. So over here, so for example, when the n equals -1, over here, so the n equals +1. They're going to give me the same value. So what -1 gives me over here, +1 gives me the same thing over there, and vice versa. You get me? And the n can be any integer. When the n equals 0, this gone and this gone, you know. And that's 5 pi by thing, you know. If you look at it, anything where the n over here, so give me the negative version of the n, give me the same thing over there. And n can be is an integer, can be a positive or negative whole number. So yes, these two answers give me the same angles, depending for varying values of n. They give me the same angles for varying values of n. So I think most people have done it this way though, over here, so rather than this way. You get me? I think it work out more straightforward this way. But they are the same. They are the same. These two results produce the same result. Same. Right? So for any value of n over here, the negative of that same value give me the same result over there. So the two results are the same really and truly, because I've said n is an integer. That's why it's so important to put this in. That n is in. And an integer is a positive or negative whole number. That is it. Anyway, what else? Who have a question? Nobody else have a question? You guys are done? Yeah,
So I have a
sure.
question.
All right. Which one?
2023,
2023.
5,
2023, where are you?
5B, part C2.
Listen, no? 2023, see here, we're doing some questions on it.
Yeah,
Which
the
one is
question
it?
after that, the follow-up of the Kuhn one.
Which one? This one?
Both of them
Yes, sir.
same.
This?
Yes. Yeah, and the other one.
You didn't watch the video. I sent the video in the group yesterday of this video, of this paper. Yeah, we didn't
So
get
you're gonna
time
watch
to
it after.
You don't have time to watch it, you have to sleep.
So
You need to go and sleep. You need to go and sleep. Yeah, all right. So this question says, so I'm going to do it just as I would do it in the video. This
Sir,
question
Marco,
says,
no, you know, sir.
yeah, man, cool. This
Yes,
question
sir.
says, the manufacturer of a container, good luck tomorrow, yeah? All the best. This question says, the manufacturer of containers want to make a container in the shape of a cuboid with an open top. The container is made of flat sheet of metal of length 16 centimeters and with 16 meters and with 30 meters. Squares of length 1 centimeter. Squares of length X meter, are cut from each corner of the sheet to create the size of the container. Show that the volume of the container is this. So I'm going to show you what I did in the video. I said, okay, the container, flat sheet of metal that they use is like this. And it is what? 13 by 16 to begin, right? And they take out these little corners, square corners. Take out that X square corner from here. And take out that X square corner from here. They cut them out, right? The square corners, square. See what I say? Squares of length. So take out that square from each corner. Take out one from here. Take out one from here. And take out one from here. So these gone. These are cut out. These are cut out. Remember now that they are each X, right? So each of them is just X. So basically, if I zoom it up, then this is a X by X. This is a X by X. And this is a X by X. And this is a X by X. Those are removed. When I remove those, you're gonna get back this shape left. Something like this. Bam, 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 bam. Agreed? That's what is left, right?
yes, sir.
So this side becomes x minus 60 minus 2x. Right? So this then is 60 minus 2x. If I write it in blue, 16 minus 2x. And this side becomes 13 minus 2x. So because remember, you take alpha x here and take alpha x here. And here for this one, you take alpha x here and take alpha x there. Show it again. You take alpha x here and take alpha x here from the 16. And take off x here and take alpha x here from that, right? Then from this now, what they do, they take these like a flaps. These like a flaps. And they fold them up. So they take these and they fold them up. So you fold this up, fold this up, fold this up, fold that up. When you fold them up, that's where you get a cuboid. So you fold them up now, you're gonna end up getting this thing, cuboid, like something like this. Bam, 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 bam. Maybe I need to make that a little bit longer. Show that it's actually rectangular. this piece. That's what they get. If I show the back here, a different color, say black, right down here, right across here, right across here. So that is the container. So the container now is gonna have a direction. Okay, see these little corners, you fold up this little piece. This little piece is fold up and turn that, like, right? These vertical pieces, we fold it up. So the height of the container is X. The width right here, so is 13 minus 2x. And the length over here is 16 minus 2x. And then you want the volume. So the volume is the product of those three sides. See that? So what the volume of this thing now?
Sir, so all of that for just 2 marks. 2 marks?
It's weird. It's weird.
That's
No, you don't need to draw the diagram now. You need to be able to visualize that. That's what they're gonna get. You can't watch that. I think it's unreasonable because I know that this question was stolen from GCE many years ago. But when GCE give you this question, you know, then give you a diagram, you know, like this, you know, and describe it, you know, and so you can see what will happen. But this one not even give you a diagram, nothing. They don't even fully complete the description. You have to use your own imagination now to realize that you're gonna get that. And as I say, it's only 2 marks. The mathematics for it is 2 marks, but to figure out that this is what happened is another story. Because I don't think they give sufficient information up here. They stop short by describing. They could have described more what happened. You get me? But that's what it is. That's why doing a lot of questions is so important, because you encounter these questions and you see other times when they explain it better. But that is it. But you know, a good observation is only 2 marks. But yeah, a lot of things for 2 marks. But as I say, if you could read this information and visualize that you take off 2x off of each side, and the x will take off, fold up and form this, so then you know you could draw this one time without doing all of that. But I do this just for you to see the steps of what happened. You get me? So I'm putting the little x's inside this now. So like these little corners are x, 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 and x. And you fold them up and them become the height of the thing. Then the volume is the product of those three things now, right? So the volume becomes this x times this times this. And I'm sure when you expand this out, you're gonna get this thing. Alright, I'm sure. This is a 13 minus 2x. Let's do it. So v equal x into. I'm gonna expand this one first. I'm gonna calculator. Still Jesus. All right, I expand these 2 brackets first. The first is going to be 16 times 30. What is that? 16 times 30. 16 times 30. 208. So it's 208. Then we're going to do the far product and the near product. So the far product is going to be 2 times 16, which is 32. And the near product is going to be 2 times 30, which is 26. So I'm going to be subtracting 32 and that is what? 58. So I'm subtracting 58x. So it's minus 58x. And then this time, this gives you a positive 4x squared plus 4x squared. Shift this over some. Right? That's what they get. And they multiply through by the x. You multiply through by the x to get this exact same thing that they gave us. So I'll put this cube term first, this time this first. So you get 4x cubed. And this times this comes minus 58x squared. And this time this gives you plus 208x. That's what I had up here. See there? Same thing. All right. And then next part of it over here, what does it say? It says using the method of second derivative, determine the height x that will maximize the volume. So we have to differentiate the volume. Because the volume is maximum in dv by dx equals 0. So we have to differentiate this and put t equals 0. So copy this, paste over here. So we have differentiated that. Put up here so. So they don't want the maximum volume, they just want the value of x that will make it maximum. All right. And generally speaking, so this is a curve with a cubic function like that, shape like this, you know. So if you find the stationary values of x is a smaller one, that's going to correspond to the maximum. When the x cubed term is positive, the graph, the cubic function graph, has this shape like that. When it is negative, if this was a negative, then it will have a shape like so. The minimum come before the maximum. When you know those things, it's just easier. Mathematics is just easier. The more things you know. And anyway, when you don't know, you have to go through the process. So anyway, so I'm going to write dv by dx equals, differentiate this, I'm going to get 12x squared. Differentiate this, I'm going to get minus this thing 116 minus 116x plus 208 plus 208. And then now, you're gonna have to put this equals 0 and solve for the x, because dy by dx is 0 at these maximum points. So you're trying to find where that is. This can be divided through by what? 4 divided by 4. So divide this by 4, you get 52. 116 divided by 4. 29. So it's 4 we can divide by. So we divide 2 by 4, we get 3x squared minus 29x. Divide this by 4, we get 52 equals 0. So you go 208 divided by 4. Yeah, 52 equals 0. And then can this be factorized? I don't want to find out. I'm gonna complete the square. I'm gonna use a quadratic formula. So the x is gonna be minus b, which is 29, plus or minus the square root of b squared, which is 29 squared, minus 4 times the a, which is 3, times the c, which is 52, all over 2a, which is 2 times 3. All right, so that's gonna give me more values of x. 2 values of x, and if I decide which one of them actually maximizes the thing. So we are gonna have to do the second derivative. That's what it says after all. It's telling us what to do. So I'm gonna put them in the calculator and put the 2 values there. So it's gonna be fraction 29. Let's go for the plus first. Square root. It's gonna be 29 squared. Then minus 4 times 3 times 52 all over 6. So I'm getting 7.29 as one value, and the other value is with this is a minus. I'm getting 2.38. Those are my 2 values that I'm getting. That or that, right? So one of them gonna maximize. This is the one I'm gonna maximize it, you know, the lower one. The lower one gonna maximize. But we'll differentiate this again. First derivative. So we're gonna go d2v to get the nature with the second derivative. That is the nature the question asking us for. Which one is maximized? So it's d2v by dx squared equals, differentiate this now. I'm gonna get 24x minus 116 as my second derivative. Now what I'm going to do, I'm going to plug this value in. I know that's the one, because as I told you, the cubic function with the cube is positive, the maximum comes before. So since I get these two from my stationary points, this one is for here, and this one is for there. So the smaller one corresponds to the maximum. Right? So I can just test it in this right away and prove it, right? So I'm going to put it in here and say at x equals 2.38, the d2v by dx squared becomes 24 times 2.38 minus 116. It's going to come out negative. Let's test it. So it's 24 times 2.38. Let's put the 8. I left off the 8 here. 2.38. Right? 24 times 2.38 minus 116. So you see, come out negative. So this is less than 0. Therefore, maximum when the x equals 2.38. That's what the sum must find, right? Determine the height x. That's it, 2.38. The next part now says determine the maximum volume. So the maximum volume now, you plug this back in the volume formula right there to get the maximum volume. So the volume max would be 4 times 2.38 cubed minus 58 times 2.38 squared. Let me shift this over a bit. And then it's going to be 208 times the same value. 208 times the same value. So I'm going to have redo. I'm going to have, what is it again? A plus? Yeah, plus 208 times the same value. So I'm going to be plus 208 times 2.38. Work that out, and that is the answer. So whatever that gives you is the max. All right. I think I'm gonna call it. I'm tired. All right. You guys good? Got more questions to do?
So I have one more, but it's an older paper. So
Which paper?
2011 is an induction question I wasn't able to solve.
All right, 2011. I don't even think I have a 2011 in this document. Might have a describe it for me. I think I have 2011 in this device. Let me see.
They said proved by mathematical induction.
Hold on. Let me look first. Hold on. Let's look. Hold on. Let's look. Let me look. Don't think I went past 2011 in this device. I have it, but not in this device.
Sir,
Yeah?
they usually said compound interest questions on the paper.
Anything with upon add math can come on the paper. When there's so much past paper, you don't mind you see them on it? Much
No, I
past
don't
paper
see
you do?
them.
Much past paper you go through?
Like 10 or 9.
So how much you see?
Huh?
How many you see? Compound interest.
I don't see any.
So where
So that-
about?
Oh, all right, sir.
You must know your syllabus, you know. When you do any subject you do, you must know your syllabus. Me sure them not going to compound interest in a syllabus. Compound interest and C6 something.
No, sir, because it's in the pure math book. That's why I asked you.
If it's not a pure math book or some application,
Oh, all right,
some
sir.
application of something else. But the topic of compound interest could have never be on pure maths. Could never be on pure maths. Compound interest and then something as CSEC. If you get a question on compound interest is applicable, is application to something, some other topic. And they're using the compound interest to apply. So they will be applying some other mathematical concept that's on your syllabus to a compound interest situation. I'm not going to give you a question a test upon compound interest. It's crazy. And I pure maths here though. All right, other question go. I can't find it.
Right.
Hold
So it
on
says-
a second. I'm big on my screen. I'm write it and tell me what you're proving. 2011. Is that summation?
Yeah, well, no, not a summation, a divisibility.
All right, go on now. Let me hear it.
They prove by mathematical induction that n by n squared plus 5 is divisible.
Hold on. N times n squared plus 5, that?
Yeah, yes, sir.
Yeah. Is divisible by?
6
Divisible by 6.
for all positive integers of n.
All are for n greater than some value. For all. N no start like greater than equal to 3 or something like so. Not like that?
No, it's a all.
All. All right, cool. Now let's see. Let's see. I think I remember the special case question now. So let me tell you something about this question now. You have to know your stuff enough. There's gonna come a point in this question, right? Tell you what gonna happen. It's the ones where they give you like something in the power. Those very easy and straightforward. It's once you get down into these where the n is not in the power anymore. There's gonna come a point in the proof, right? Where you're gonna have to use this thing that says the product of two consecutive numbers is an integer. So like this, k times k plus 1. Yeah, it's gonna come a point where you have to use the fact that k times k plus 1 is equivalent to 2 times something. Product of two consecutive numbers is always even. You know that, right? Product of two consecutive numbers is always even. This is something that everybody should know. Anywhere you have the product of two consecutive numbers, k times k plus 1, it is even to a no, it is even. Can be expressed as 2 times something where the q is an integer. All right? At some point, this will apply in this one. All right. I told you before. Let's see if I'm telling the truth. All right, let's do it. Let, boom, bang, let Pn be such that. Let Pn be such that. Let Pn be such that this n into n squared plus 5 is equal to 6 times x. As it divided by x, it can be that 6 times x. Where the x is an integer, I can put a natural number because everything is a positive. So you could put a natural number. And n is a natural number. All right? First step. Show that it is true for n equals 1. No, you see me, I don't want it in this format. I'm going to expand it and get my n cubed. I'll show it, tell you why later. So I'm going to write it as n cubed plus 5n equals 6x. So you don't give me this, I'm writing it as this format. I'm going to tell you why later. All right, when I reach my induction phase, I'll tell you why. So I'm writing it like that. Then I'm ready now. Step 1. For n equals 1, right? For n equals 1, plug the 1 in there. You're going to get 1 cubed plus 1 cubed, 1 cubed plus 5 times 1 is actually equal to 6 times 1. So P1 is true because it's equal to 6, right? Which is same as, so we say it, you know, this will always be equal to 6 times some integer. Yeah, the integer is 1 this time. So P1 is true. This means that P1 is true. P1 is true. Step 2 is to assume it is n equals k. For n equals k, you're basically going to be replacing in this expression the n with k, and I'm going to change that to q. Instead of x, I'm going to write q. So I'm going to get k cubed plus 5k. I'm going to put it equals 6 times some other quotient. I'm not going to put back x, put something else. Where I'm going to tell them now that the q is still an integer. And so here we assume pk is true. Here. Assume pk is true. Shift this over a little bit. All right. We'll come to the induction phase. Now, this is a key step now where I tell you why I separated these. Because I'm able to make this my subject. Because I'm going to need to remember substitute something from this down here, the next step. So right here, I'm going to make this my subject and use it as my trigger for my substitution, my next step. So I'm going to write this as k cubed would be 6q minus 5k. If I am lucky and I find this in my next expression, well, good. But if I don't, I can substitute for k cubed to work out itself. That is why I may expand this. All right, I'm telling you that why. So ready now, boom bang. So then I'm gonna go now for step 3, which is my induction phase. Step 3, which is to say for n equals k plus 1, and this is the step we have to be careful. I'm gonna take this k plus 1 and drop it here and there. So I'm gonna get k plus 1 cubed. Erase that right better. K plus 1 cubed plus 5 times k plus 1. You can't write no equal 6 times, no. You have to show what this equal to, and you're looking to use this result in it. So I'm going to shift this to the side here. So I have more space to show what it is actually equal to. So I have to write now what this is actually equal to. Not put no 6 not yet. Make it work out to the 6 times something for itself. That's what you all have to remember. Let it work out to the 6 times something for itself. All right? That's the key step right here. So I'm going to expand this and expand that and consolidate the values. And I'm going to look, I have to use this in there somewhere. Maybe I can find a way to use this, you know. Right? But if not, I definitely will be able to use this. But let's expand this first. So this becomes, when I expand this one, it becomes k cubed plus 3k squared plus 3k plus 1. And I'm adding these, which is plus 5k plus 5. That's what I get when I expand a perfect, this cube. I get this. Right? That's what we get to expand the cube. Right? And then now, remember now, all of this now, must come down equal 6 times something when we're done. That's what that must happen. And I have to use this result in there somewhere. So if you notice, I can maybe use this, because it's here, k times, I can maybe use with this, this and this. Can replace it with the 6 cube. Yeah, it works like a charm. Beautiful. So I don't need this. I don't need that. So I'm going to replace this k cube plus this 5k with 6 cube. Let me set it up. Let me set it up. So I'm going to go and write this now as k cube plus 5k. That's this and this. Then you see this. You see this and this? I'm going to factorize 3k out of it. I'm going to get plus 3k. I'm going to get k plus 1. So the magic here now. And then this 5 and 1 is 6 plus 6. The magic is in right here. This is where the magic is, right here. If you don't know, say this can be written as 2 times something, 2 times anything, 2 times m, where m is an integer. Then you can't finish this proof. Get me? Telling you, I told you it would happen. I told you. Let's get back to it. So I don't need this anymore. So I'm gonna just erase it, right? Because I'm able to use that this and this is 6q. So I'm gonna drop the 6q right inside there. So see it here now. This becomes 6q plus, this is 6, plus 6. Can put the 6. I'm trying to pack up my 6. Plus this 3 times k plus 1. See here, this is where the magic happens in this question. If you don't know this, you can't finish it. This is a key step right here to finishing this. You see this k times k plus 1? That's a product of 2 consecutive numbers. But remember now, the k even, then the k plus 1 odd. And if the k odd, then the k plus 1 even. So the product of these 2 consecutive numbers will always be equal to an even number. And an even number can always be written as 2 times some integer. So this right here, I'm going to write it as 2 times m. And this is where you have to tell the examiner. The product of 2 consecutive numbers is even. Let me write it. Is even. This is even. This is an even number. It is even. And an expression that is even can be written as 2 times some constant, where the constant is an integer. So I'm going to replace this with 2m. That's it. When I do that, I get 6q plus 6 plus 3 times 2m. Here's my 6. Beautiful. 6q plus 6 plus 6m. 6 into q plus 1 plus m. Now, q is an integer and m is an integer, and this is 1. So it means that everything here is an integer, and therefore it has been shown that even this pk plus 1 is true because we have shown that it is equal to a multiple of 6. See that? Because inside is an integer. So we can draw the conclusion and say, therefore, pk plus 1 is true if pk is true. You're done. You just draw a conclusion line now, line 4. Write the conclusion. So therefore, by mathematical induction, Pn, original statement Pn is true for all n which are natural numbers. Oh, you like that? Oh, you like that? Oh, you like that one, Mr. David?
Yes, sir. Thank you, sir.
You learn something, don't forget it, ever. The product of two consecutive numbers can be replaced with an even number. And if you don't know that, you can't finish a proof here. Cannot finish this proof if you don't know that. And you get this situation every time you're doing a divisibility type where the n is not in the power. Once the n is not in the power, you're going to end up having to deal with this at some stage in the proof in order to finish it. All right, just remember that. Majority of them will give a like 6 to the n or 9 to the n minus 1. So when n is in the power, you don't have any problem. But once the n is not in the power, as was the case for this one, and it's a divisibility you're doing, you're gonna have to conquer it using this knowledge. Because at some point, you're gonna have to replace this with some 2 times something to finish it. All right. So I finish you off with something nice there. Okay? Yes?
So this is not a question to do, it's just like a thing to confirm, right? When you differentiate, you get the function for the gradient of the tangent, right?
You get the gradient function. Yes.
For the tangent.
It's for the curve as well. It's for the curve. It's for the
integration for the curve.
Hold on. It is the gradient function for the entire curve. But remember that at particular points on the curve and the tangent have the same gradient. So yes, in essence, you're getting it for tangents to the curve as well. Remember, every point on the curve, the gradient different. That's why you have a gradient function, a function that gives you gradient at different points. So each time you put a value of x in that function, it is telling you what the gradient is. So it is called a gradient function. It gives you values of gradient at various points. Just that at any point, the curve and the tangent at that point will have the same gradient. So technically, it is the gradient function for tangents as well. Because the curve is not only one tangent. Every point have a different tangent, just as though every point have a different gradient. Understand?
Yes, sir.
You have a question? I could do a question, man. Give me a question where relate to it. Come on.
No, sir, I don't have a question. It's just
You don't have any?
Yeah.
Right. If you find any, you send it to me tonight. I'll do it for you.
Sir.
Okay, sir.
Yes?
Sir, in the exam, we can use pencil, right? They won't penalize us if we use just pencil.
All my life, I've used pencils in all my exams. Know why?
Right.
Know why I use pencil? Because pencil can be erased. You can't erase a pen.
Right.
Just make sure the pencil is dark enough that it can be seen properly, faint. And make sure that you have a nice, large, clean eraser in case of erase anything. Because if you notice the paper, they don't give a lot of space to write. And if you make mistakes and you want to change something, you just don't have a lot of space to write. You get me? And it happens. So I've always used pencils in my exams. Always over the years. And I actually recommend it to my students to use pencil. For that simple reason that if you make a mistake, you can erase it. You can't erase pen. A lot of times you're doing a question, you have to be crossing this out, crossing that out. By the time you finish, you think you can't read it. A lot of crossing out. When you erase it, you're good to go. You can just erase it right over. Just make sure the eraser is very clean eraser. You want the pencil to be dark, but not so dark that when you erase something, it is still showing. You get me? When you erase something, it must be erased. Cool?
All right, sir. Yes, sir.
That is it. Anybody have another question? All right, so Shadi, you in particular.
Yes, sir.
You in particular, Miss Shadi. I don't know about Tessema, I don't know about David, I don't know about Anthony. But I'm telling you, you have to give each question a specific amount of time. I can work it out with this paper right now, what that time is. I look on the 2023 paper and see what that time is. I think it's 25 minutes. I can work it out. You cannot be working blind in the exam. You cannot be working blind. Every question is 25 marks on the paper. And look, every question is the same amount of marks. So look at it. Where is it? 25 marks for question 1. See, where is this one? 25 marks for question 2.
Sir, how long will the exam be? 3 hours?
2 hours, 40 minutes. What was yours? Or 2.5 hours, I think. Where's the time? See there? 2.5 hours.
That's crazy.
2.5 hours. All right, so I'm going to do the maths now before I leave. So 2.5 hours, this is 150 minutes, don't it? Divided by 6. What that work out? That's how long each question must get, you know? 150 minutes. Divided by 6. What I know?
25.
See that 25. You can't give no question more than 25 minutes. None must get more than 25 minutes. These are the papers are 1 mark per question paper. There are some questions they're so lengthy. It's like you can't spend 25. You can't do them in less than 25. But you cannot cause that to not allow you to get the questions that you can do. The worst thing is to don't finish. And when the exam done, right? You reach. So you reach. So you reach. This is where. Take this off. So you reach. All right. So you reach here, so. So you reach right here, so. And exam done, right? Exam done. So you done number 5. And you reach right here, so. And when you look on a number 6, you see something that you could have done. Sometimes number 6 them easy to, you know. You look on a number 6, you start to see things that you could have done. Like them integration here and so. You see things only that you could have done. Number 6, if you watch the video on a question, I still can hear. I mean, the length is a long video. We don't have a time for it. But a paper last year never normal. I'm telling you the truth. This paper last year was not normal. You get me? It was not normal. But anyway, the point is you have to limit your time on each question. Do not spend more than 25 minutes on a question. See there? If you can get each question done in about 22 minutes, right? You work with 22 minutes. It means you have 12 minutes at the end to check back over. You know, something like that. Couple minutes. If you work each question, so you give each question 23 minutes then. 23 minutes. They have 2 times 6 minutes, which is 12 minutes at the end to check back over. So you give each question 23 minutes, save 2 minutes per each question to go back or check. So it's 23 minutes if you give each question. I would have said 20. I personally would have just said 20. But then if you give each question 20 minutes, you're gonna have 5 times 6. You have 5 minutes times 6. You have 30 minutes to check over. Think like a bit. So you're closer. You really want check over time to be around 10 minutes. So give each question 23 minutes. Don't make 23 minutes pass per question. Worst 25. Definitely not. 25 minutes must not pass. So you see what I talk about, you see the maths. You have to give each question a specific amount of time. Every question carries the same amount of marks, even though you know that some of them more difficult than others because of your strengths and your weaknesses. You have some topics where you're strong in, you have some topics where you're weak in. So I just start the paper, them all them easy question, you have to try and make up some time, you know. Them easy question, you know, them truth table and all them something, you know, polynomials and them things. You have to shut through them question fast and make up some time. So what you must do, you must know, so okay, if it's 25 minutes per question, right? You must know, so when you reach question 2, a 50 minute start. When you reach question 3, a 75 minute start, which is 1 hour 50 minutes and so on. You have to kind of know where you are as the exam go on. You have to know where you are. Each question must get 20. When I'm doing an exam, and I say I'm giving each question 25 minutes, let me show you how I operate. If I'm doing an exam, right? I'm gonna say I'm giving each question 25 minutes. I'm now past 25 minutes for a question. And I'm doing question 1. I'm gonna do that part there. I'm gonna do that. I'm working down. I'm gonna do that. I'm gonna come down. I'm reach this. I'm gonna do that. And then when we reach right here, so now I'm gonna do this, right? And let's say we reach right here, so now I'm gonna see 26 minutes on the clock. I'm gonna left this, I'm gonna do this. I'm gonna left that. I'm gonna over this. So time for this question has started. Gone over there, so. Because if you keep giving away time on the questions, then what got me that cumulatively you won't be able to do one whole question, you're not gonna finish. Cannot give away time on the questions. Worst thing is if you do a question with hard. You better go through let me tell you another thing about the exam paper. You must notice it. Each part is a different question. So look at number 1. A is a truth table. B is a proof by count exam. Different question that over here, C. C is a polynomial. 3 different questions that Look again. D is a logs. And this is like a search part of the logs. And it's still different from this, It's still a different question that relate to that, They're not related, That's what the question is. So question 1, like it have about 5 different questions in it. 1, 2, 3, 4, 5 different questions. So any part, if I'm not comfortable with this part, for example, me leaving it. Do the parts of a question that you know. Right? Come over question 2, all right? You can do the proof here by adjective. That's a straight line. Right? This, you can do them here, we do them. When we do them there, I look on a question and I can't do it. And this look like a troublesome to me. May I leave that one? It's a whole question that by itself. So you can leave out some parts of question if you look on it and you don't know what to do right away. Look troublesome or whatever. Do questions where you read it, you know what to do. You read this, you know what to do. You do it. You read this, you know what to do. You read that, you know what to do. You do it. You read them. You read this one, you don't know what to do. Okay, leave that one. Put an asterisk on it. I'm coming back to you. Move on. Go through the paper and do the questions that you know. Remember that each part is a different question. Like part D relate to part C. Some questions like that. But usually, once you see the letter, it's a different question. When you see the part number, sometimes it's the same question. When you see the part, like part 1 and part 2. And even sometimes when you see that it's a different question, like in the low-cost question sometimes. So once you see a different question, look on all these 2. Now, them 2 questions are related, not 2 different questions. So maybe you can do the part A, but you can't do the part B. It's 2 different questions. This 2 different questions. So you go to the paper and you do what you know. Do what you know first. Do the part where you know first. The paper is blank. But you go back and look, you see that the big blank space there, you never do it. You realize you never do it. If you start do it and never finish it, asterisk it. They said this and never finish it. Make a mark and you move on. You understand me? You have to be strategic, man. Very important. So you do all the question here, you do the part there, and you come up part B, and you don't know what to do. Leave that. Leave it. Don't waste your time on question where you don't know what to do. You want to go through the paper and do all the questions that you know what to do when you read it. And you don't have to be thinking it out. Thinking takes time. Thinking takes time. The less you have to think, the better. You just want to be doing. How you do that? Do the questions that you know how to do first. And then the ones where you have to think through and so you come back to those later. You understand? When you're super good, when you're good and you master it, Then you can do the paper from front to back. You just do start at number 1, then number 2, then number 3. And you just keep on, you just go on because you're good like that, you know it. Right? I'm telling you, even me, you know, at this stage, if I'm doing an exam paper like this, and especially like our Pure-Maths can be diabolical sometimes, you know. It can be diabolical sometimes. You get me? You know, because sometimes Mr. Boyd really set this question in an exam, somebody under pressure, time pressure, and I set a question like this in an exam. The Pure-Maths paper, a lot of the times, is the length of it. It's very difficult to finish because the questions take a lot of time to do. You understand me? It take a lot of time to do. It's like they don't allow for any time to think. You just read a question and do. You get me? So therefore, you have to be strategic in what you do. Don't just be there doing a question and forget about the time. You have to be mindful of the time all the time. You have to constantly be aware of the time. Don't give no question more than 25 minutes. Do the parts of questions that you know first. Exhaust all of those first. Let it be that you spend time doing the parts of questions that you have to think afterwards. So if you come out of the exam and never reach one question, make it be a question that you wouldn't be able to do anyway. Or you would be able to do it well anyway. Do not come out of the exam room and leave a question in there that you would have been able to do. That don't make no sense. All the questions on the paper that you know how to do, you must do them. That is it. All right. You can send me messages if you like. You hook up on something and you want to send me a message. If I can do it for you, I'll do it. I'll jump up out my bed and do a solution for you and send it also. Okay, guys? Not a problem. Do well. Okay? Mr. Day, Mr. David, Mr. Anthony, and Mr. Seema. Burning the night lamp with Mr. Shaw. All right, guys, that's it. Good luck tomorrow.
Thank you, sir.
Thank you,
Okay, so
sir.
thanks.
Good night.
All right, good
Okay,
night.
so thanks. Good night.
All right, bye-bye.
Yeah.